For years, hollow points have dominated the self-defense ammunition conversation. But here in 2026, more and more concealed carriers are moving in a different direction. It's not because traditional hollow points suddenly stopped working. It's because newer ammunition designs are delivering greater consistency, improved barrier performance, and better reliability across a wider range of defensive situations. After watching extensive testing, especially through common barriers, I stopped asking whether these newer rounds were worth considering. Instead, I started wondering why I hadn't made the switch sooner. Today, we're looking at the ammunition technologies changing defensive carry, and why so many experienced shooters, instructors, and law enforcement professionals are embracing them. My interest in solid copper hollow points really took off while shooting a Glock 19 equipped with a threaded barrel and a KKM compensator. Running Barnes TAC XPD 115 grain plus P ammunition, the pistol produced tight groups at 15 yards, cycled flawlessly, and after 50 rounds showed virtually no barrel fouling. That experience made one thing clear: solid copper hollow points aren't simply another premium ammunition trend. They're purpose-built for performance. Unlike traditional jacketed hollow points that combine a lead core with a separate jacket, solid copper designs from Barnes TAC XPD, Black Hills, Honey Badger, and Remington HTP copper are machined from a single piece of copper. There's no jacket to separate, no lead core to fragment, and no soft material to deform after striking hard barriers. Their biggest advantage is excellent weight retention combined with highly consistent barrier performance. Copper maintains its structural integrity under extreme pressure, allowing these bullets to penetrate automotive glass, steel, and other common obstacles without losing their effectiveness. In calibrated ballistic gel, after passing through 4-layer denim and laminated windshield glass, Barnes TAC XPD consistently penetrates roughly 12 to 14 inches while still achieving reliable expansion. Instead of suffering jacket core separation, the TAC XPD opens into 6 sharp petals that cut tissue efficiently while maintaining excellent penetration. Another benefit is cleaner suppressor use. Traditional lead core ammunition can quickly build fouling inside suppressors, while solid copper loads burn cleaner and significantly reduce maintenance requirements. For shooters running optics, suppressors, or simply seeking maximum reliability from a defensive handgun, solid copper hollow points deserve serious consideration. Solid copper hollow points are only part of the modern defensive ammunition landscape. Another rapidly growing category doesn't expand at all, yet often delivers outstanding terminal performance. Fluted solid projectiles first caught my attention after watching Lehigh Defense Extreme Defense ammunition pass through automotive glass before carving an impressive wound cavity in ballistic gel, all without expanding. There was no mushrooming and no petals, just a precisely machined copper projectile doing exactly what it was designed to do. Unlike hollow points, fluted solids such as Lehigh Extreme Defense and Extreme Penetrator rely entirely on geometry. Machined from solid copper, these bullets use specially designed flutes to redirect soft tissue outward at high velocity, creating both a substantial permanent cavity and significant temporary cavitation through fluid displacement rather than expansion. Because they don't depend on an expanding hollow cavity, they continue producing consistent terminal effects even when conventional hollow points clog with clothing and fail to open. They also tend to feed exceptionally well in compact carry pistols. Without a large hollow point cavity, they transition smoothly up feed ramps, making them an excellent choice for pistols such as the SIG P365, Glock 43X, and Springfield Hellcat. Penetration generally falls within the 16 to 18-inch range through FBI-style barriers including heavy denim, plywood, and automotive glass, results supported by calibrated ballistic gel testing and independent evaluations. An additional benefit is legal flexibility. Because these projectiles contain no hollow cavity, they are often treated differently than conventional hollow points in states with hollow point restrictions, including places like New Jersey. Rather than exploiting a legal loophole, they represent an entirely different approach to defensive ammunition design. Another innovative category changes terminal performance in an entirely different way by tumbling rather than expanding. Watching Fort Scott IIe ammunition fired through a Glock 19X demonstrated just how effective this concept can be. The bullets entered soft barriers cleanly but quickly became unstable inside ballistic gel, creating highly disruptive wound paths. Tumble-on-impact ammunition isn't designed to mushroom. Instead, these solid copper projectiles intentionally destabilize after entering soft tissue, rotating end over end to produce significantly more complex wound channels than a straight-line projectile. Fort Scott Munitions 2i remains the best-known example. These bullets remain perfectly stable during flight, but are engineered to yaw rapidly after entering tissue, ballistic gel, or similar soft media. They neither fragment nor expand. Instead, controlled tumbling creates extensive internal disruption while maintaining deep penetration. Testing commonly shows penetration between 12 and 18 inches depending on barrel length, with tumbling typically beginning within the first 2 to 3 inches of tissue, exactly where rapid energy transfer becomes most valuable. This design is especially attractive for compact carry pistols. Many short-barreled firearms struggle to generate enough velocity for traditional hollow points to expand consistently. TUI projectiles rely primarily on geometry instead of velocity, allowing them to perform more predictably from shorter barrels. They also feed exceptionally well in compact firearms, including slim single-stack .380 pistols and small-frame revolvers. Like other non-hollow point designs, they may also be legally advantageous in jurisdictions that restrict conventional hollow point ammunition, making them attractive for carriers who frequently travel across state lines. For shooters who still prefer traditional expansion but want greater durability, bonded jacketed hollow points offer an outstanding balance between proven design and modern engineering. While helping a friend zero his SIG P229 using 147-grain Federal Tactical bonded ammunition, accuracy certainly impressed me. What stood out even more, however, was how consistently the bullet stayed intact after passing through demanding barriers. Bonded hollow points retain the familiar expanding design, but the lead core is permanently bonded to the surrounding jacket. This prevents jacket separation after passing through steel, drywall, automotive glass, or other hard obstacles. Anyone who has watched a conventional hollow point shed its jacket during ballistic testing understands how quickly terminal performance can suffer. Bonded construction virtually eliminates that weakness. Top-performing examples include Federal Tactical Bonded, Spear Gold G2, and Remington Golden Saber Bonded. These loads are specifically engineered to meet or exceed demanding FBI testing standards, particularly through laminated windshield glass and similar barriers. They provide dependable expansion while retaining roughly 90 to 100% of their original weight, even after penetrating hard intermediate materials. Because they remain conventional hollow points, they generally do not avoid hollow point restrictions in states like New Jersey. Even so, their outstanding barrier performance explains why they remain trusted by law enforcement agencies across the country. Rather than reinventing defensive ammunition, bonded hollow points simply perfect one of the industry's most successful designs. Another modern solution addresses one of the biggest weaknesses of conventional hollow points, feeding reliability. One of the smoothest loads I've ever run through a Springfield XDS was Hornady Critical Defense 115-grain FTX. Chambering was flawless, with none of the nosedives or feed ramp issues sometimes associated with wide-mouth hollow points. Ballistic tip ammunition places a polymer insert inside the hollow cavity, serving two important purposes. First, it creates a more streamlined bullet profile for smoother feeding in compact semi-automatic pistols. Second, upon impact, the polymer tip is forced backward into the cavity, initiating reliable expansion even after passing through heavy clothing or other debris. Hornady's flex tip expanding technology dominates this category, appearing in both critical defense and critical duty product lines. Critical defense emphasizes civilian concealed carry, while critical duty is optimized for barrier performance that closely follows FBI testing standards. Critical defense expands reliably after heavy clothing, whereas critical duty incorporates tougher jackets and interlock technology for improved barrier penetration. Both generally achieve 12 to 15 inches of penetration while producing consistently reliable expansion. Ballistic tip ammunition also tends to be easier to find and more affordable than many premium copper or specialty defensive loads. For shooters whose pistols occasionally struggle with traditional hollow points, polymer-tipped ammunition often improves both feeding reliability and terminal performance without reaching boutique pricing. Not every defensive environment calls for maximum penetration. That's exactly where frangible ammunition excels. While training inside a concrete shoot house with steel targets, centerfire frangible ammunition offered tremendous peace of mind. Splashback was dramatically reduced, ricochet risk dropped considerably, and there was far less concern about overpenetration. Frangible ammunition isn't intended for defeating barriers or creating the deepest possible wound channels. Instead, it's specifically designed to reduce collateral risk in confined environments. These projectiles are typically manufactured from compressed copper and tin powder, sometimes enclosed within a thin jacket. When striking hard surfaces like steel, concrete, or brick, they rapidly disintegrate into fine particles. Against soft tissue, however, they remain intact long enough to penetrate approximately 9 to 12 inches before breaking apart. That makes them particularly appealing for home defense, apartment living, and other situations where neighboring rooms or neighboring homes may be separated by only a few interior walls. Manufacturers such as Centerfire, Liberty Civil Defense, and Winchester all offer lead-free frangible options that continue gaining popularity among homeowners concerned about pass-through shots and excessive wall penetration. Liberty's lightweight 50-grain 9mm loads can exceed 2,000 feet per second, producing extremely rapid energy transfer. The trade-off, however, is reduced penetration compared to conventional defensive ammunition. Frangible rounds aren't the ideal solution for outdoor defense or situations requiring barrier penetration, but inside homes or shared living spaces, they provide a valuable balance between effectiveness and reduced collateral risk. The newest generation of defensive ammunition combines multiple technologies into entirely new projectile designs. After testing Lehigh-controlled chaos through a friend's AR platform pistol, what impressed me most wasn't expansion. It was controlled fragmentation. The projectile entered like a solid bullet before intentionally breaking apart several inches into ballistic gel. That engineered behavior represents the future of hybrid defensive ammunition. These loads don't fit neatly into either the hollow point or solid copper category. Some use fragmenting monolithic bullets like controlled chaos. Others incorporate multiple internal cores or engineered cavities that separate only after reaching a predetermined depth. The objective is simple: maintain controlled penetration before creating significant internal disruption while still meeting the FBI's preferred 12 to 18-inch penetration standard. Manufacturers are also experimenting with pressure-activated expansion systems that respond differently depending on impact velocity and target resistance. Other designs combine multiple materials such as copper and polymer, or use directional fragmentation to further refine terminal performance. Many of these products remain relatively expensive and occupy niche markets, but they point toward the future of defensive ammunition. The focus is shifting away from simple expansion and toward controlled, intelligent projectile behavior. Traditional hollow points certainly remain effective and continue serving countless concealed carriers well, but modern ammunition is increasingly emphasizing consistency, barrier performance, and predictable terminal effects under real-world conditions. As defensive technology continues evolving, those qualities are becoming just as important as expansion itself.